start off with trigonometric formulas and identities that are required. So when I say trigonometric formula, it means it comprises of trigonometric table, the periodicities, and the reciprocal identities, the complete list. So that's exactly what I'm going to give you here. So foremost, let's start with something basic identities. So the first and foremost one which we all are supposed to know is sine squared theta. I'm using theta, you can use theta, alpha, beta, or phi or x, because this just mentions an angle. Since it is conventionally used, I'm using theta there. So the first one is sine squared theta positive cos squared theta is equal to 1. The next one is sine squared theta is equal to 1 minus cos squared theta. The third one is cos squared theta is equal to 1 minus sine squared theta. And then 4, you got secant squared theta negative tan squared theta is equal to 1. And the fifth one is cosecant is equal to 1. So this comprises of basic identities. Now there is something called reciprocal identities which we will have to know. Reciprocal identities. So though they are all such presented in this following fashion. 1 over, in fact let me write it like this, 1 over sine theta is equal to cosecant theta. Number 2, 1 over cos theta is equal to secant theta. Number 3, 1 over tan theta is equal to cot theta. Right? So that's a very important formula that you will have to know. 1 over tan theta is equal to cot theta. Now these formulas can also be interchanged. Say for example, you can likewise write sine theta is equal to 1 over cosecant theta. You can just flip them, right? And cos theta is 1 over secant theta. So that is also possible, right? I have mentioned it for cosecant theta and secant theta, but we can also mention it in terms of sine theta. But usually they don't do it, but apparently it's always possible. So from your, in this case, formula number 6, I can write tan theta is equal to 1 over cot theta. So these can be used whenever there arises a demand, there arises a requirement. So we need to keep an open mind when it comes to problem solving. So it is imperative to mention here that all these are taken from right-angled triangle. Right-angled triangle. So you can use the word right-angled triangle or right triangle. It doesn't matter because it has an angle 90 degrees. So let's move on. Now the next important information that we will have to have in our minds is what is called as the trigonometry table. Now you will have to apply some memorization techniques here, because that would come in handy, because we cannot be applying the formulae or resorting to the calculator every time we encounter an angle. So if you have it in your mind, stored in your mind, you can be efficient when it comes to solving questions against the race that time puts up. So let's start. So the first row will have angles in degrees, right? I'm giving it both angles in degrees, and the second row is going to have angles in radians. RAD stands for radians. So usually we start with 0 degree and then 30 degrees followed by 45 and then 60 and then 90, 180, 270 and then 360. That's it. So these are all standard angles which you have to know. So in terms of radians, 0 degrees is 0. This is going to be pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. This is pi. This is 3 pi over 2 and this is 2 pi. Right? So now comes the famous sine. So when we're talking about sine, we're talking about sine 0. Right? So sine 0 is 0, sine 30 is 1 over 2, sine 45 is 1 over root 2, sine 60 is root 3 over 2, sine 90 is 1, sine 180 is 0, sine 270 is going to be negative 1, 3 pi over 2, and this one is going to be 0. So this is for sine. And then you got cos 0 is 1, cos 30 is root 3 over 2, cos 45 is 1 over root 2, cos 60 is 1 over 2, cos 90 is 0, cos 180 negative 1, cos 270 that's going to give me 0, cos 360 that's going to be 2 pi, that's going to be 1. So that's for cos. Now tan 0 is 0. Tan 30 is going to be 1 over root 3 because tan is sine over cos. So sine divided by cos 1 over 2, root 3 over 2. So you flip it, you get 1 over root 3. And tan 45 is 1 and tan 60 is root 3. Tan 90 is infinity. Tan 180 is 0, right? And tan 270 is infinity again because of the involvement of pi over 2, and tan 360 is going to give me 0. So these are for the main trigonometric arteries, right? So now comes the reciprocal. So sine 1 over sine is cosecant, right? So what I can do now is I will start, instead of starting with cosecant, because cosecant and the sine are further away. So let me start something closer to tan. So that's going to be cotan. So cot. So cot 0 is actually, cot is 1 over tan, right? So 1 over 0 will be infinity. And this one is going to be root 3. This is going to be 1. This is going to be 1 over root 3. Tan 90 will give me 0 here, right? And tan 0 is going to be infinity. So this is 180 because tan 180 is 0. When it comes to cot, it's going to be infinity. And this is going to be 0 and this is going to be giving me infinity. So that's fine. That's a nice way to place the values. So now comes after cos, I should say after cot, you got cos. Cos is actually secant theta, right? So let me write that down so that we can go up further like that. So secant theta is nothing but 1 over cos, right? So secant 0 is 1. This is going to be 2 divided by root 3. I can write it like this. This is going to be root 2. This is going to be 2. This is going to be infinity, right? Because secant 90 is 0. So this is going to give me infinity. This is going to give me negative 1. This is infinity. And this is going to be 1. So that is for secant. So let me just draw the block. So now comes cosecant. Cosecant is actually 1 over sine, right? So 1 over 0, that's infinity. This is 2. this is root 2, this is 2 over root 3, this is 1, this is infinity, this is negative 1 and infinity. So this is what we have got for cosecant. So that's a nice way. So all that you need is 1, 2, 3, sine theta, cos theta and tan theta, and you will be able to complete this beautiful table. So we will move on, students. Now next comes what is known as sum and difference formula. So this is a very important concept you will have to know. The first one is sine of A positive B is equal to sine A cos B positive cos A sine B. Formula 1, formula 2. Sine of A minus B is equal to sine A cos B minus cos A sine B. Cos of A positive B is equal to cos A cos B minus sine A sine B. Cos of A negative B is equal to cos A cos B positive, and it is negative, it becomes positive, and this positive becomes negative. So it is going to be sine A sine B, right? Now we got a formula for tan of A positive B, this is very important, is equal to tan A plus tan B divided by 1 negative tan A tan B, and tan of A negative B, that's also critical, right? So that is going to be equal to tan A negative tan B divided by 1 positive tan A tan B. Now I can actually prove this, that tan of A positive B is equal to tan A positive tan B divided by 1 negative tan A tan B. So let me give you this proof. So I want to consider the right hand side, which is tan A plus tan B divided by 1 negative tan A tan B. So I know tan is sine A over cos A, and tan B is sine B over cos B divided by 1 negative sine A cos A sine B cos B. Now if you were to take the LCM, cos A cos B, this will give me sine A cos B plus sine B cos A divided by this, again I'm taking the LCM as cos A cos B, so that's going to be cos A cos B negative sine A sine B. So cos A cos B can be cancelled. Sine A cos B plus sine B cos A, what is that? That's nothing but sine of A plus B. So this is equal to sine of A plus B divided by cos A cos B negative sine A sine B. Cos A cos B negative sine A sine B. What is that? Cos of A plus B. So write that, cos of A plus B. Now what is sine over cos? Tan. What is the argument? A plus B. So which is equal to the left hand side. So this is just proof for you to understand. So having given that, let me move on to formula number 6. I have added this to 6. So in 6 we will have to look into double angle identities. So let me state the double angle identities. Now just some other information. Now I can similarly replace tan by cot. So let me just consider that. So tan is 1 over cot, right? So this is going to be 1 over cot of A positive B, which is equal to 1 over cot A plus 1 over cot B divided by 1 negative 1 over cot A times 1 over cot B. Now this is equal to, if I were to take the LCM as cot A, cot B, this is going to be cot B positive cot A divided by cot A, cot B negative 1 divided by cot A, cot B. Cot A, cot B, cot A, cot B can be cancelled. So you have 1 over cot of A positive B is equal to cot A plus cot B divided by cot A, cot B negative 1. So if I were to flip this, I move this, and I push that down. So I would get, therefore this would mean I got cot A, cot B negative 1 divided by cot A plus cot B. I've already moved this to the other end, so it's going to be cot of A positive B. So you got a beautiful formula here. Students, as a continuation of our formula list, let us see double angle identities. So the first one features sine to x. I've already mentioned to you this formula, but I will also give you another deviation to this. So sine to x, we know this is equal to 2 times sine x cos x. This can be further rewritten as 2 times tan x divided by 1 positive tan squared x. Formula number 2, cos 2x is cos squared x negative sine squared x. We already know this. Just for being consistent in mentioning this, this could be further rewritten as 1 negative tan squared x divided by 1 positive tan squared x. So as a homework, you can attempt to prove this. Left side is equal to right side. In certain cases in the lecture sessions, I've already given you proofs of some of these identities. Now cos 2x can also be rewritten as 2 times cos squared x negative 1, which can be further rewritten as 1 negative 2 times sine squared x. And 4 tan 2x is equal to 2 times tan x divided by 1 negative tan squared x. Formula number 5, secant 2x is equal to secant squared x divided by 2 negative secant squared x. And you got a formula for cosecant 2x, which is nothing but secant x times cosecant x divided by 2. Okay, now from this there are other deductions that are possible. So let me just consider 2 times sin x cos x. Now what I wish to do is I would like to divide by 1, and then I would like to rewrite 2 times sin x cos x over 1 as sin squared x positive cos squared x. It's fair enough, right? Now I would like to take cos squared x out as a common factor, and that would give me sin squared x over cos squared x positive 1. But sin x over cos x is equal to tan x, and this would mean sin squared x over cos squared x is equal to tan squared x, right? So I can substitute that. So this is equal to 2 times sin x cos x divided by cos squared x of tan squared x positive 1. Now I would like to cancel a cos and a cos here, giving me 2 times sin x divided by cos x times, I'm going to write tan squared x positive 1 as 1 positive tan squared x. Right? Now let me divide the numerator and the denominator by cos x. So that would give me 2 over sin x divided by cos x divided by cos x divided by cos x times 1 positive tan squared x. Cos x gets cancelled, giving me 2 times sin x over cos x is tan x divided by 1 positive tan squared x. So I got a new formula. What is that? Sin 2x, which was written as 2 times sin x cos x, can also be written as 2 times tan x divided by 1 positive tan squared x. A very, very important formula that will come in handy in solving many questions. Now, cos 2x is cos squared x negative sin squared x. So this is an important formula also. Now, simultaneously we can have many representation for cos 2x. Since I've started with cos squared x negative sin squared x, I'm going to rewrite sin squared x as 1 minus cos squared x. So this is going to give me cos squared x negative positive cos squared x and a negative 1, which is going to be 2 times cos squared x negative 1. So this is another important formula. Now, instead of replacing sin squared x with 1 negative cos squared x, what would be the situation if I were to replace cos squared x with 1 negative sin squared x? So that's going to be 1 negative sin squared x followed by a negative sin squared x, and this is going to give me 1 negative 2 times sin squared x. Another important deduction we have arrived at. So cos 2x can also be written as 2 times cos squared x negative 1, or 1 negative 2 times sin squared x, or cos squared x negative sin squared x. Now, what we can further do is we can actually deduce cos squared x minus sin squared x again in a different fashion. So what I would do is I would like to write cos squared x negative sin squared x to be as cos squared x negative sin squared x divided by 1, now which is nothing but cos squared x negative sin squared x divided by 1 can be written as cos squared x positive sin squared x, right? Now let me take cos squared x out. So if I were to take cos squared x out, I would get 1 negative sin squared x divided by cos squared x for the numerator. In the denominator, again I wish to take cos squared x out. This is going to give me 1 positive sin squared x over cos squared x, right? Now cos squared x can be cancelled. Sin squared x over cos squared x is tan squared x. So I got 1 negative tan squared x divided by 1 positive tan squared x. You see that? This is also a very important deduction. The next one that you will have to know is sin raised to the power of 4 theta positive cos raised to the power of 4 theta is equal to 1 negative 2 times sin square theta times cos square theta. This is a very popular identity which you will have to remember. Now how do I prove it? So let me just start out like this. Consider the left hand side, which is sin raised to the power of 4 theta positive cos raised to the power of 4 theta. I'm going to rewrite this as sin square theta positive cos square theta raised to the power of 2. If I expand this, I would get 2 times sin square theta cos square theta. So I can take that out. So this is going to be 2 times sin square theta cos square theta. But sin square theta added with cos square theta is 1. So this is going to be 1 negative 2 times sin square theta cos square theta. So this is a very important formula, and it is imperative that you take note of it. Now there is another important trigonometric identity which you will have to know, and that is sin raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sin square theta cos square theta. Now I can give you the proof. So I'll start off like this. Consider the left hand side, which is sin raised to the power of 6 theta positive cos raised to the power of 6 theta. I'm going to rewrite this as sin squared theta raised to the power of 3 positive cos squared theta raised to the power of 3. Now there is a formula in algebra. We know that a cube positive b cube is a positive b times a squared negative ab positive b squared. So using this formula over here, this is nothing but A positive B. So sine square theta positive cos square theta times, and you have A squared. So A squared is going to be this raised to the power of 2. So that is going to be sine square theta. This is my A, right? But I have to raise it to the power of 2. So that would mean I got sine raised to the power of 4 theta negative AB. My A is sine square theta, my B is cos square theta. So this is going to be sine square theta cos square theta positive B squared. My B is cos square theta, squared is going to be cos raised to the power of 4 theta. So I can rewrite this. This is a formula. So I can rewrite this as sine square theta positive cos square theta is 1 times, I'm going to club these two together. This is going to be sine raised to the power of 4 theta positive cos raised to the power of 4 theta negative sine square theta cos square theta. But what is sine raised to the power of 4 theta positive cos raised to the power of 4 theta? This is the formula. You see that? Take this and substitute here. So this is going to be equal to 1 negative 2 times sine square theta cos square theta. Already there is sine square theta cos square theta. Sine square theta cos square theta can be added. So that would give me 1 negative 3 times sine square theta cos square theta. So this is a very important identity that you will have to remember. So what is the identity? The identity is sine raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sine square theta cos square theta. What is called as the cast rule. You can either call it as cast rule or the name that you would like to start with. You know, they will also mention it as ASTC rule, right? And then I will also explain to you the reduction formula. So it's a very important topic, and it's, I would say, it's the art of trigonometry. When I say art, I meant this art, right? The core concept in trigonometry. Now, if you were to take the quadrant, now we always refer trigonometry relativity with quadrant. Always we talk about the angles with reference to the fourth quadrant. So this is the first quadrant. So when I say quadrant, you spell it like this: QUADRANT, the quadrant. So this is one quadrant. So this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Of course, the angles, the measure is from 0 to 180 degrees, and then it goes up to here 270 degree and ends here at 360 degrees. In the first quadrant, we say A. So that means all ratios are positive. All ratios are positive. So what does it mean all ratios are positive? It means sine is positive, cos is positive, and tan is positive, and the reciprocals. The reciprocal of sine is cosecant theta, it's positive. Reciprocal of cos theta is secant theta, it's positive. Reciprocal of tan theta, that is also positive in the first quadrant. Now in the second quadrant, only sine is positive. Only sine is positive, and its reciprocal. The reciprocal for sine is cosecant theta, right? And cosecant theta is positive. So only these two are positive in the second quadrant. In the third quadrant, tan is positive and its reciprocal, that's cot. Only these two are positive. In the fourth quadrant, cos alone is positive and its reciprocal, which is secant theta, that is positive. So when we say exactly cast, so we talk about like the C-A-S-T, that's what we say. So have that in mind, and with some problems you will be able to gain a mastery on that. Now, having mentioned the cast rule, now let me mention the reduction formula. Now there are two important formulas which you will have to know, and they are very powerful. That is, if you were to be asked to find sine of some constant multiple of pi plus theta, the outcome will always be either plus or minus sine theta. There wouldn't be any change in this. The only thing that will change is the sign, either a plus or a minus, but sine will always be occurring with the angle. So this is one. The next formula is, if you were to be asked sine of some constant times pi over 2 positive theta, then the outcome would be plus or minus cos theta. So in this case, cos will be there no matter what, because of the fact that you got k times pi over 2. But the only change would be either a plus or a minus. So using this, we would be doing problems. Students, we would be finding now the value of the following. Now the first question is, what is the value of sine of pi negative theta? Now clearly in the formula I have given you sine of k times pi positive theta would be equal to plus or minus sine theta, depending upon the quadrant that we have. So in this case, the problem is sine of pi negative theta. Now if we were to draw the quadrant, we know all ratios are possible. Sine alone is positive here, and tan is positive here, and cos is positive. So when I say cos is positive, it means cos and its reciprocals are positive. Sine and its reciprocals are positive. Tan and its reciprocals are positive. So this is going to be 0, this is 90, this is 180, this is 270, and this is 360 degrees. Now pi negative theta, now this is pi. Now whenever you have a negative sign, you are basically talking about a coordinate or a point between 180 and 90. So remember, always negative sign means you move up, positive sign you move down. So since it is in the second quadrant, sine is always positive here. So this is going to be, I know that it's going to be sine theta because of the formula I've given you, and the sine is going to be positive. So that is the solution for the first question. Now question number 2. Let us see what would be the situation if they have given us sine of pi over 2 negative theta. I've clearly given you the formula. Sine of k times pi over 2 positive theta is equal to plus or minus cos theta. So 90 degree is over here. I already told you, if it is negative, it will move in this direction. So that means we are looking at a quantity which is in the first quadrant. First quadrant means all ratios are positive, so the sign is going to be positive, but apparently we need to have a cos theta there because of the formula. So that is the solution for the second question. So let's go and do the third question. Third question wants us tan of pi positive theta. Now remember, the formula which I've given you for sine will also go for tan. Okay, so have that in mind. So in this case, we would be looking at, in this case we're getting sine here, so we would be getting tan here, tan theta. The main point is it a positive sign or a negative sign? Is it a plus or a minus? So as I mentioned to you, 180 is over here between the second quadrant and the third quadrant, and anything positive will be located over here. So this would mean tan is always positive in this case, so it's going to be plus or positive tan theta, depending upon what you would like to say, whether it's positive tan theta or plus tan theta. Now coming to the next question, question number 4. Let's see what happens to secant of 3 pi over 2 positive theta. Now what is secant theta? Now secant theta is nothing but 1 over cos theta. So it's a reciprocal of cos. Secant theta is a reciprocal of cos. Now we have secant of 3 pi over 2 positive theta. So the question is, what would be the output? Now when it is sine, please watch here, if it is sine k pi over 2 positive theta means we are getting cos. On the contrary, if it is cos then we would get a sine. So in this case it is secant, so we would get a cosecant. Okay, so 3 pi over 2, 3 pi over 2 is nothing but 3 multiplied with 90, which is nothing but 270 degrees. So the position is over here, 270 degrees is over here. Positive sign, as I mentioned to you, positive means it will be located on this side. So over here cosine is actually a positive sign, positive ratio. Cosine along with this reciprocal, which is secant, will produce a positive ratio. So in this case we will have a positive sign. Okay, so moving on, let's do the next question. The next question is cot of 11 pi over 2 negative theta. Now what is this? Now, as I mentioned to you, when we add tan, the outcome would be cot, but in this case we got cot because of the presence of pi over 2, so the outcome is going to be tan. Now the question is it a positive tan theta or a negative tan theta? That is the decision that we will have to take. So how do we take it? Now first foremost, let us find out what is 11 pi over 2. 11 pi over 2 is nothing but 990. Whenever an angle that we get is greater than 360 degrees, we have to keep subtracting 360 degrees from this angle until we get a value which is lesser than 360. So in this case, you got 990. Let me subtract 360 degrees. So this is going to be 0. This is going to be 3. And from 9, I have to take away 3. I will get 6. So now I got 630 degrees. Again, it's greater than 360 degrees. So subtract 360 degrees from this. So this is going to be 0. I borrow 1, 13. From 13 I take away 6. That will be 7. This is 5. From 5 I take away 3. It's going to be 2. So 270 degrees is less than 360 degrees. So we stop here. So where is 270 degree? It is between the third quadrant and the fourth quadrant. So this is the point that we are looking for. Now the question is, we have negative. So negative means we go towards the left. Okay, so this is the location that we are looking for. Now in this case, tan is positive and its reciprocal is positive. That is, cot is also positive. So we have a positive sign. Simple, isn't it? So finally, let us talk about secant of 7 pi positive theta. Now what is this 7 pi? 7 pi is nothing but 7 times 180. What is that equal to? 0. 7 times 8, 7 8s are 56, 5, and 7 1s are 7, positive. We need to add 5, so we are getting 1260. So we have to subtract 360. So let's see what happens. So as I mentioned before, if an angle is greater than 360, you keep subtracting 360 from the outcome. So let me do that. 360, I'm subtracting, I get 0, 0. This is going to be 900. That's 9. So again it's greater than 360. I'm going to subtract 360 now. 0, 10 and 4. This is 8. I get 5. So 540. Again I subtract 360. So 0. This is going to be 8, 4, 180. So 180 degrees. So 180 degree actually lies between the quadrant 2 and quadrant 3. So this is the point that we are looking for. Now positive sign. Positive sign means it will go down. In this case only tan and its reciprocal cot is positive. So we will have a negative sign there. Place your negative secant theta. Next, students, we will have to deal with negative angles. What will be the situation when theta is negative? So when I talk about negative angles, we are talking about the trigonometric ratio of sine, cos and tan. So sine of a negative angle, that's negative theta, is going to be negative sine theta. A very important outcome. And cos of negative theta is equal to cos theta. And similarly, you got tan of negative theta is equal to negative tan theta. So the reciprocal of sine is cosecant. Similarly, cosecant of negative theta is equal to negative cosecant theta, and reciprocal of cos is secant. So secant of negative theta is equal to secant theta. Reciprocal of tan is cot, so cot of negative theta is equal to negative cot theta. This is called even function, and this along with this are called as odd function. And these are some of the important identities you will have to know. So to start with, sine of A positive B is equal to sine A cos B positive cos A sine B. Identity 2, sine of A negative B is equal to sine A cos B negative cos A sine B. Identity 3, cos of A positive B is equal to cos A cos B negative sine A sine B. And finally, cos of A negative B is equal to cos A cos B positive sine A sine B. So when we talk about compound angles, these are the compound angle formula connected with sine and cosine. So having mentioned this, let's move on, students. Now, having given you the compound angle formula for sine and cosine, now let me give you the compound angle formula involving tan and cot. So let me write down now compound angle identities, in fact. I call them as identities involving tan and cotan. So the first and foremost important one is tan of A positive B is equal to tan A positive tan B over 1 negative tan A tan B. Formula number 2, tan of A negative B is equal to tan A negative tan B divided by 1 positive tan A tan B. So this is for tan. Now let me write the equivalent for cotan, that's cot. So cot of A positive B is equal to cot A cot B negative 1 divided by cot A positive cot B, and cot of A negative B is equal to cot A cot B positive 1 divided by cot. In this case it would have to have a reversal here. So this is A minus B, so we won't have it as cot A negative cot B, we'll have it as cot B negative cot A. So that is how it would be obtained as. Now we can verify all of this, right? It's possible to verify each and every formula, and that wouldn't be a difficult task. So having given this compound angle formula, I would suggest that you practice them thoroughly so that it becomes second nature for you. Let me just show you the proof of one of these formulas. So I would like to show you how exactly cot of A negative B is equal to cot A cot B positive 1 divided by cot B negative cot A. Now what I wish to do is I would like to consider the right hand side. So what do we have in the right hand side? We got cot A cot B positive 1 divided by cot B negative cot A. Now I can rewrite cot A as cos A over sin A times cot B as cos B over sin B positive 1 divided by cot B as cos B divided by sin B negative cot A as cos A divided by sin A. Now if I were to take the LCM for the numerator, this is going to be sin A sin B, and I would have cos A cos B positive sin A sin B, right? This entire thing is divided by, if I were to take the LCM as sin A sin B, I would get cos B sin A negative cos A sin B. Now this has to be divided by sin B sin A. Clearly you can see sin A sin B sin B sin A, they can be cancelled, giving us cos A cos B positive sin A sin B divided by, I can write this as, okay, let me write it as cos B sin A negative cos A sin B. So this is what I've got. Now cos A cos B, and I've got sin A sin B. So this is going to be cos of A minus B divided by, now I got sin A cos B negative sin B cos A. So what is this? This is nothing but sin of A minus B, right? But what is cos over sin? Cos over sin is nothing but cot, and what do we have? We got A minus B, and what is that? That is nothing but equal to the left hand side. You see that? So hence proved. So that's the end of solution. So having given you all this, there is one more important formula you will have to know. So this is 1, 2, 3 and 4. There is a fifth one which is very important, and that is tan of pi over 4 plus or minus A, which is equal to 1 plus or minus tan A divided by 1 minus or plus tan A. Now this result can be easily proved from tan of A plus B formula, right? So I can just show you this. So if we were to ask tan of pi over 4 positive A, we can just use tan of A plus B, which is nothing but tan A plus tan B divided by 1 negative tan A tan B, which is in this case is going to be tan pi over 4 plus tan A divided by 1 negative tan pi over 4 times tan A. Tan pi over 4 is 1 positive tan A divided by 1 negative tan pi over 4 is 1 times tan A. So have that in mind. This is 1 plus tan A divided by 1 minus tan A. So this is what we have got for tan pi over 4 positive A. So this is the result. So the result can also be obtained for tan pi over 4 negative A. So the sign will get reverted. So having given you all this formula, we can move on to do application oriented questions. So when I mean application oriented question, I mean how exactly or where exactly we apply these compound angle trigonometry identities. Students, we are going to see further important identities which would come in very much handy. The first one is sine of A positive B times sine of A negative B is equal to sine squared A negative sine squared b. This is a very important identity. The question is, how are we going to get it proved? So let me just start off like this. Consider the left hand side, which is sine of a positive b times sine of a negative b. We know the formula for sine of a positive b, or a plus b, which is sine a cos b positive cos a sine b. This has to be multiplied with sine of a minus b, which is nothing but sine a cos b negative cos a sine b. Right? So this is a plus b times a minus b, which is nothing but a squared minus b squared. So this is rewritten as sine squared a times cos squared b negative cos squared a times sine squared b. I would like to rewrite cos squared b as 1 negative sine squared b, and similarly I would like to rewrite cos squared a as 1 negative sine squared a. I would like to distribute the quantity, so that would give me sine squared a negative sine squared a times sine squared b negative sine squared b negative negative positive. This is sine squared a times sine squared b. Negative sine squared a times sine squared b would be cancelled with positive sine squared a sine squared b, thereby giving me sine squared a negative sine squared b, which is equal to right hand side, hence the result. Right, so this is a very important identity that we would be using in future. So having obtained this proof, we will move on, students. So similarly, there are two more identities which are important, and that would be involving cos of a positive b multiplied with cos of a negative b, which is equal to cos squared a negative sine squared b, is the second one. And there is the third one, which is nothing but tan of a positive b positive c, which is equal to tan a positive tan b positive tan c negative tan a tan b tan c divided by 1 negative tan a tan b negative tan b tan c negative tan c tan a. Now next comes what we call as the transformation formulae. So we looked into the product when sine of a positive b is multiplied with sine of a negative b. Now it is addition, right? Summation. So the first one is going to be sine of a positive b positive sine of a negative b is equal to 2 times sine a cos b, followed by sine of a positive b negative sine of a negative b is equal to 2 times cos a sine b. So have that in mind. So in this case it's cos a sine b. And formula 3, cos of a positive b positive cos of a negative b is equal to 2 times cos a cos b. And formula 4, cos of a negative b followed by a negative sign cos of a positive b is equal to 2 times sine A sine B. Now, having given you all this, if I were to take A positive B to be equal to C and A negative B to be equal to D, if I were to add them, this is going to be 2A is equal to C positive D. Therefore, A is C positive D divided by 2. Now, if I were to take the value of A and substitute it over here, then I can suitably extract the value for B, which would be C negative D divided by 2, right? Because instead of adding here, if you were to get rid of A, let me show you that also. So I get A positive B is equal to C. In this case, A negative B is equal to D. I can subtract and get rid of A. So this is going to be negative, this is going to be positive, this is going to be negative. So A gets cancelled, giving me 2 times B is equal to C negative D. Therefore, B is equal to C negative D divided by 2. So this is the value for B, right? So if I were to substitute them in formula 1, what would happen? So therefore, I can rewrite 1 to be as sine of A positive B. In place of A positive B is going to be sine C positive A negative B, which is going to be sine D is equal to 2 times, in place of A it's going to be C positive D divided by 2 sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is a important formula. Now I can just change everything. So formula 2, let me just write that down. Formula 2 can now be rewritten as sine of A plus B, which is nothing but sine C negative sine D is equal to 2 times cos of A, which is C positive D divided by 2 times sine of B, which is C negative D divided by 2. And formula number 3 is going to be cos A positive B, which is cos C positive cos of A negative B, which is D, is equal to 2 times cos of A C positive D divided by 2 times cos B, which is C negative D divided by 2. And formula number 4 is also rewritten as cos of A negative B, which is cos D negative cos A positive B C cos C is equal to 2 times of sine of A, which is C positive D divided by 2 times sine of B, which is C negative D divided by 2. Very important formula. Students, I wish to give you further identities which are very important, which would come in very much in handy to solve questions. That would be sine A times sine of 60 negative A multiplied with sine of 60 positive A is equal to 1 over 4 times sine 3A. So this is one identity. The second one is for cos. Cos A times cos of 60 negative A times cos of 60 positive A is equal to 1 over 4 times cos 3A. Now if we were to divide 1 by 2, then we would get the third one, and that is going to be sine A over cos A. That's nothing but tan A. Similarly, sine 60 negative A divided by cos 60 negative A, that's going to be tan of 60 negative A. Sine 60 positive A divided by cos 60 positive A, that's going to be tan of 60 positive A. 1 over 4 will be cancelled with 1 over 4. giving me tan 3a. So that's a very good identity we have got, students. Now you may be wondering, how is it we are going to achieve a proof for this? Now let me just give you that. Foremost, let me state the identity. This is what we have been given. Sine A times, now I would like to write this as sine of 60 positive A times sine of 60 negative A. Fair enough, it's not going to make any change at all, which is equal to 1 over 4 times sine 3A. We are expected to prove this. So what I would like to do is, I would like to start off by stating, consider the left hand side. What is that? Sine A times sine of 60 positive A times sine of 60 negative A. Right? Now we know a very important result. What is that? Sine of A positive B multiplied with sine of A negative B is equal to sine squared A negative sine squared B. We just saw this result. So this would mean I can now rewrite sine A times sine of 60 positive A times sine of 60 negative A to be as sine A stays as it is, parenthesis, this is going to be sine squared of 60 negative sine squared A. Now what is sine 60? Sine 60 is root 3 over 2, right? So sine squared 60 is going to be root 3 over 2 squared, which is nothing but 3 over 4. So I would substitute that. This is equal to sine A divided by 3 over 4 negative sine squared A. If I were to take the LCM as 4, this is going to be 4 times sine squared A divided by 4, which I can rewrite it as 3 times sine A negative 4 times sine A times sine squared A. That's going to be sine cubed A divided by 4. I can take 4 out and rewrite this as 3 times sine A negative 4 times sine cubed A, which is equal to 1 over 4 times sine 3A, which is equal to the right hand side, hence the result, right? It's a beautiful result. Now let's go on to triple angle identities. So they are as follows. I start with 1. Sine 3x is equal to 3 times sine x negative 4 times sine cubed x. Very important. Cos 3x is equal to 4 times cos cubed x negative 3 times cos x. So formula number 3, tan 3x. Tan 3x is equal to 3 times tan x negative tan cubed x divided by 1 negative 3 times tan squared x. After this comes what is called as half angles, half angle identities. So let me state them. First one, sine x over 2 is equal to square root of 1 negative cos x over 2. Number 2, cos x over 2 is equal to root of 1 positive cos x divided by 2. Of course you got plus or minus in these terms, but I don't want to specify it. And then you have tan x over 2 being equal to root of 1 negative cos x divided by 1 positive cos x. A very important formula, this one. Tan x over 2 is equal to root of 1 negative cos x divided by 1 positive cos x. Right. So you can simplify this and you have special differentiation, or I would say other variations for this. So if I were to multiply, let me just show you that. This is equal to root of 1 negative cos x divided by root of 1 positive cos x, right? Now let me multiply the denominator and the numerator with 1 negative cos x, right? And this one by 1 negative cos x. So if I were to do that, this is going to be equal to root of 1 negative cos x raised to the power of 2 divided by 1 negative cos squared x. Now this is going to be root of 1 negative cos x raised to the power of 2 divided by sin squared x. Right? You got the square root. Now if you were to apply the square root, this is going to give me 1 negative cos x divided by sin x. So you see the change, tan x over 2 is equal to root of 1 negative cos x divided by 1 positive cos x, and it is also equal to 1 negative cos x divided by sin x. So that is a very important outcome that you will have to pay attention to. So we have the total list, and probably I can also give some inverse trigonometric formulae. So sine inverse of negative x is equal to negative sine inverse of x. That's one. Number two, cos inverse of negative x is equal to pi negative cos inverse of x. Number three, tan inverse of negative x is equal to negative tan inverse of x. And let me utilize the space here. 4, cosecant inverse of negative x is equal to negative cosecant inverse of x. Number 5, secant inverse of negative x is equal to pi negative secant inverse of x. And number 6, that's cot inverse of negative x is equal to pi negative cot inverse of x. Now we have almost covered all of the formulae except for a few, which is involving the triangle. So those formulas are called sine angle formula and cos angle formula, right? So I will just mention to you how exactly we can extract those. So imagine you are given a triangle like this. Let me draw this triangle. You got A, B, C, side A, side B and side C. Now this is also called as the sine law, right? And this law is as follows: sine of capital A divided by A is equal to sine of capital B divided by B is equal to sine of capital C divided by C. So this is called the sine law. Now for the same triangle you have what is called as the cos law or cosine law. Now that law is as follows. So let me write that down. A squared is equal to B squared positive C squared negative 2 times BC times cos of capital A. Similarly, B squared is equal to A squared positive C squared negative 2 times AC times cos of, in this case it has to be capital B, and c squared is equal to a squared plus b squared negative 2 times ab cos of capital C. So that looks good. Now when we are dealing with these questions, when the topic comes, I will do elaborate problems. As of now, I think this is a good place to stop. Before I could stop, I would like to mention the vertex that you see here, A, B and C, they are actually angles. You got the angle A there, angle B here and angle C here. So you would be given one of these angles and asked to calculate the sides or whatever that is required of. So that is the formula list that you all have to know to master trigonometry.